Hi everybody, this is Miss Moran. Welcome to Unit 1, Video 1. This is your first video lesson of the year. We're going to be covering polynomial operations. You'll need to be taking notes throughout the video. You may pause it whenever you need to, and then resume when you're ready to start again. At the end of the video, you'll find a list of problems that we'd like you to try out of your textbook. When you come to class the next time, we'll be looking at your notes to see if you have any questions on the examples in the video, in addition to the questions that will be asked at the end of the video. Let's go ahead and get started. What is a polynomial? A polynomial is a monomial, or a sum or difference of monomials. So in order to really define a polynomial, we have to first define a monomial. So a monomial is a constant, a variable, or the product, which means multiplication, the outcome of a multiplication, product of constants and variables. We're going to go ahead and give you some examples here. A monomial versus not monomials. So a monomial could be 3. A monomial could be x. And then we have the product, it'd be 5x, or negative 10x to the third. It can also be the product of multiple variables. For example, x, y, that is a monomial because it is a product of x times y. Examples of things that are not monomials: addition or subtraction of constants and variables are not monomials. Also have negative exponents. If I have y to the negative second power, this is not a monomial. Also cannot have a fractional exponent. And lastly, we cannot have a variable exponent. So we have examples of what monomials are and examples of what monomials are not. When we talk about the degree of a monomial, we're looking at a single monomial, and we're going to talk about the exponent. So the exponent here is 1. If I talk about x, y, they each have an exponent of 1, so the degree is 2. 5x squared y cubed. The degree of this monomial is the sum of the exponents, so the degree is 5. Let's continue. The degree of a polynomial. Since we defined polynomials as a monomial, or the sum or difference of monomials, we can take a look at the degree of a polynomial as the largest exponent on a single, wow, look at that. Monomial. And I will explain that more as we go through these examples below. A constant. A constant is defined as a number without a variable, would be one definition, and we're looking for something to be constant, means it doesn't change. So 5 is a constant, negative 7 is a constant, 3.2 is a constant. There is no variable attached to this number, which means it will never change its value. Okay, to classify a polynomial by a number of terms, and to classify the polynomial by degree. The number of terms, x, gives us a monomial because there is one term. X plus 4 is a binomial. The prefix means 2, bi. X squared plus 3x minus 1 is a trinomial. The prefix meaning 3. And anything beyond that, anything with more than 3 terms, so 4 terms or larger, we generalize as polynomials. That does not mean that x is not a polynomial. X is a polynomial. X plus 4 is a polynomial, but we can be more specific and call them monomials, binomials, and trinomials. But anything beyond 3 terms, we just stick to the generalization of polynomial. To classify a polynomial by degree, if the degree of a polynomial is 1, back up. If the degree of the polynomial is 0, we call this constant. If the degree is 1, we call it linear. If the degree is 2, we call that quadratic. If the degree is 3, we call it cubic. If the degree is 4, it is quartic. If the degree is 5, it is quintic. And anything beyond that, we will just say a 6th degree polynomial, a 7th degree polynomial, an 8th, 9th, or 10th degree polynomial. But this is how they are defined, and we probably would stop somewhere around quartic in our vocabulary. Standard form is to put the terms of the polynomial in descending order. If we talk about descending order, we're meaning that we start with the largest degree down to the smallest degree. The largest degree is our degree of our polynomial. The smallest degree can only go as small as being a constant, which would mean it would have just a number. Not all polynomials have a constant, or they do, we call it 0, and we don't write it. The coefficient. A coefficient is the number, we're going to write it simply, attached to the variable. For example, 3x. 3 is our coefficient. Co means it goes together. Leading coefficient. The leading coefficient, when something is written in standard form, is the first coefficient. If you're unfamiliar with these words, these are going to get easier as we go through some examples. I'm going to give you some examples here, and we're going to classify the polynomial, after writing it in standard form, by degree and the number of terms. So go ahead and write these in your notes. So our first example is 5x squared plus 10x cubed minus 2x plus 7. The first thing we were asked to do is to write this in standard form. I'm going to change ink color so you can see. To put this in standard form, we start with the largest exponent. That would be the 10x cubed term. And then we'll go in descending order. So 5x squared minus 2x plus 7. We're going to talk a little bit about some other vocabulary here. So 10 is our lead coefficient. Classifying this by degree, well, the degree of this polynomial is the largest exponent that we see, which would be 3, making this a cubic polynomial. By the number of terms, because this has more than 3 terms, we're just going to generalize it and call it a polynomial rather than something more specific. So this is a cubic polynomial. 7 is our constant. Let's try another example. Negative 6x plus 11x squared. If we go ahead and write this in standard form, we would have the largest exponent first, 11x squared, minus 6x. 11 is our lead coefficient. Our constant is 0, or we could say we don't have one. This is the highest exponent we have, the degree of our polynomial, is 2. meaning this is a quadratic two terms binomial. Let's try one more. All right, for this example, to write it in standard form, we would want to put the largest exponent first. Actually, it's already in standard form. It's in descending order. So we can say this is standard form. We'll just rewrite it so we don't have an answer blank that's empty. And then we would say, well, what is the degree of this polynomial? Well, if I look at the first term, 7x squared y cubed, I would have to add them together. So my degree is actually a fifth degree polynomial. We can write this as quintic. We could also write this as fifth degree. And then if we were to decide this by the number of terms, we're going to classify it by the number of terms. It has 3 terms, making it a trinomial. Very good. Okay, the next ones you may actually move through a lot quicker than to follow me along. So if you want to, you may go ahead and add and subtract these together, or add and subtract the polynomials, and then check your answers. I'm going to go ahead and speak through my answer, so if you need to follow along, feel free. If you want to work on your own, pause the video, and then you can just check the answers when we're done. So for an example number 1, I am adding the polynomials together, which means I'm going to be adding my coefficients but keeping my exponents the same. It's combining like terms. So I have 8x cubed plus x cubed, making that 9x cubed. I have an x squared, which I would want to write next because I'm keeping this in standard form. Then I have a negative 4x and a positive 5x, leaving me with only 1x, which you may write as 1x or just x. And lastly, my constant is 7 and a negative 3, leaving me with 4. Example number 2. I see I have 2 squared terms, but this one is being subtracted. So the best thing I could do is to write 6x squared minus 7x plus 1 minus 2x squared. This is minus a negative, making it plus 3x, and then minus a positive, making it minus 6. Now I can combine like terms. 6x squared minus 2x squared makes 4x squared. Negative 7x plus 3x makes minus 4x. And 1 and negative 6 makes minus 5. And that is my final answer. Examples numbers 3 and 4 are multiplication. I'm going to distribute because I'm multiplying a monomial times a trinomial. Here our exponents do change because when I multiply variables together, the exponents will be added together. So I get 4x cubed minus 12x squared, and then I get plus 20x. This is in standard form. My last example, you may use the word FOIL. It is not a word that you will find Mrs. Eggerding and I using, but we will use distribution because we're going to distribute the terms from the first binomial to the terms of the second binomial. This is like a double distribution. So x squared times 3x gives me 3x cubed. X squared times 2 gives me 2x squared. Negative 5 times 3x is negative 15x, and negative 5 times 2 is negative 10. And this is our answer. Here, when I multiply 2x plus 5x quantity squared, I'm going to want to write it twice, 2x plus 5y times 2x plus 5y. I'm going to show you another way to multiply, and that is using this box method, sort of like a Punnett square that you may find in biology. I'm going to write on the top and on the side the 2 binomials that I'm multiplying together. They happen to be the same thing. It doesn't really matter where you write them then. If I multiply 2x times 2x, I get 4x squared. If I multiply 2x times 5y, I get 10xy. Here I'll get 10xy again. And then lastly, I will get 5y squared. To write this polynomial in the correct order, I'm going to start with the variable alphabetical order, so that's 4x squared, followed by adding these two together, giving me 20xy, and lastly 5y squared. I'm going to show you the same multiplication for number 6 using this Punnett square idea. It doesn't matter which way you write it, so I'm going to write the x plus 4 over here, and I'm going to write the 3x squared minus 9x and plus 1 on the top. I'm going to multiply 3x squared times x, giving me 3x cubed. X times negative 9x is negative 9x squared, and 1 times x is just x. On this column, I'm going to have, or this row, I will have 12x squared, a negative 36x, and a positive 4. I'm going to write these in standard form. So I will have 3x cubed plus 3x squared minus 35x plus 4. I really like the idea of using the boxes because I end up with a very neat set of work. I don't lose any terms. I don't forget any of these arrows as I draw them. So this way I know I have to fill in all of those, which means I know I'm distributing every term from the binomial to every term of the trinomial. For this last one, I'm going to multiply these first two together. You may use the box method, you may use arrows, you may use the word FOIL if you want. And I will get x squared plus 5x minus 3x minus 15. I'm going to combine like terms and get x squared plus 2x minus 15. And then I'm left to multiply that by the 2x plus 1. You may use the box, you may use arrows, you may use whatever you choose to multiply that correctly. I'm going to set it up as 2x and a 1, x squared 2x minus 15, and I'm going to complete the box. 2x cubed, 4x squared, negative 30x, x squared, 2x, and negative 15. And I can go ahead and write my answer in standard form by choosing the largest exponent first, combining like terms as I move throughout. And I end up with 2x cubed plus 5x squared minus 28x minus 15. All right, you've actually completed your first video lesson. So now I'd like you to try on page 33, numbers 19, 22, 26, 27, 29, 35, 39, 49, and 63. They should be pretty quick, won't take you very much time, and bring those to class the next time we see you.